So this video, I just want to talk a little bit about solving exponential equations and showing you that the graphs connect to the solutions to the exponential equations. So the big idea is that whenever you have an equation, you are doing the same thing to both sides to undo what is part of the equation. So let's start with a pretty simple example, something like 10 to the x plus 3 equals 1003. You might be able to solve this just sort of by guessing and checking. But if you want to go through and show your steps, what you're doing is undoing the parts of the problem. So the opposite of a plus is minus. So we take away 3 from both sides, leaving us with 10 to the x equals 1,000. And then the opposite of an exponential is a logarithm. I like to think of it as saying logs cancel bases. So if I wanted to get rid of 10 to the x, I do a log base 10 of both sides. Notice that I'm not doing the 10th power. The 10th power would help me if I had, say, x to the 10th power equals 1,000. Then I would do the 10th root to get rid of the 10th power. But here we have base 10 of x, so we have 10 raised to the x, so I do log base 10 to cancel the base of 10. So x is equal to log base 10 of 1,000. And as a reminder, if I just write the word log without specifying the base, it implies that to be 10. So let's look at this as an equation, just so you can remember what we're talking about. We're talking about 10 raised to the x plus 3. We're talking about 1,000 y value. Both y values. If I zoom way out, you'll see, where's 1,000? There it is. You'll see that the two things intersect right there at 3. Interesting. I don't know why it's saying 2.999. It should say 3. Oh, excuse me, equals 1,003. Oh, it'll say 3. 1,003. And I knew that because I chose numbers that worked out nicely, and the log base 10 of a number is just equal to the power of 10 that lands on that number. So there's 3 zeros, so the power of 10 is 3. Let's look at another example. Let's look at 2 raised to the x plus 2 times 5 equals 80. So in this example, first thing we're going to do is do the opposite of times 5. I do it to both sides. In the first example, my minus 3 canceled my plus 3. In the second example, my divided by 5 cancels my times 5. That leaves me with 2 to the x plus 2 is equal to 16. In the first example, my log base 10 canceled my base of 10. In the second example, my log base 2 cancels my base of 2. So I have to do log base 2 of 16. Now I have what's left over in the exponent, and I have log base 2 of 16. You can grab a calculator, or you can count up on your fingers until you land on 16. 2 times 2 is 4, times 2 is 8, times 2 is 16. So I get 4. Finally, opposite of plus 2 is minus 2. Just like times cancel divide, just like log cancel base, minus cancels plus, and it gets x equals 2. I can represent this with my two graphs just to check my answer. It's always possible I made a mistake. 5 times 2 raised to the x plus 2. Oops, I want the x plus 2 in the exponent. One graph. Y equals 80 is the other graph. Zoom in a little. Oops. Zoom in a little bit. There we go. 2 comma 80. X equals 2. Last example. This is the sort of thing you might see. Let's say that I had, 24 e to the 0.02 t equals 50. So this is the sort of problem you might see if you're doing some sort of word problem where you start with 24, maybe 24,000 bacteria, and it grows at 2% a year, and you want to know when it reaches 50,000 bacteria. Opposite of times 24 is divided by 24. So what is 50 divided by 24? 2 point something. 0.08. So we've got e to the 0.02t, 2.083. Opposite of a base of e is a log with a base of e. The log with a base of e has a special abbreviation, ln. ln is just an abbreviation for log with a base of e. So ln just means the natural log. And so let's do that. I can't do the natural log of 2.08 in my head. That'd be weird if I could. After I do that, I get 0.73. And then the last thing is dividing by 0.02. So I'll just take this answer, divide 0.02, and I get t is about 36.7. I hope by now you trust that it's going to work out, but let's just double check. So we have 24 e 2.02 t. There we go. We have y equals 50. I'm going to scoot around a little bit. I hit it right here. It says 36.698, exactly like what we said. So in this video, I just wanted to show you solving a couple examples of solving log equations and showing you how the graph intersects at the same x value that is the solution to the equations. So let me know if there's anything that was confusing and I will help you out.